Welcome, everyone. I'm so glad you chose to spend this time with us, whether you're here with us in person or tuning in virtually for Summit. It's just a privilege to have you, and what a wonderful day for it. We're in New York. How many people are here? How many are local? Yeah. We really wanted to come here this year. There's so many great partners that we've worked with for years that are in the city, and it's just a joy to have Summit this year. I want to just say a couple words about the event before we get started. We run this event every year for the builders, so we focus on practical content. This is all about the folks who have brought GraphQL to the companies that you are at, that have brought it into the hands of your users, who've learned so much along the way. And so our whole objective here over the next couple days is to learn from each other and grow together. If you look around, under the name on your name tag are the companies, and you're going to see some really amazing companies that are household names, companies you really respect. Learn from them. There's so much here, not just on stage over the next 2 days, but at topic tables at lunch, in the hallways. We've really tried to set this up so that there's just a wealth of information that you can get from each other, and that's really the goal of what we've done here. A few talks that really popped out for me. You can all build your own agendas, but we've got some really cool stuff here. The team from Cox Automotive, for example, is giving a talk on how they're integrating GraphQL with their API gateway infrastructure in Kong. I think that's a really important design point. We've got amazing stuff on security. Wiz is here. We're going to do a joint session together. Coinbase needs no introduction. GraphQL at enormous scale. Block is doing really great work with AI and using AI and GraphQL together for a better development experience. Rumor on the street is Juicer, this is an EV charging company in Europe, is doing really interesting stuff with real-time GraphQL, and I'm told they have some things to share at their talk later today. And T-Mobile's here. They're doing something really interesting using GraphQL as sort of an internal accounting and billing mechanism inside the company for API consumption. So much good stuff. We also have a lot of talks from the Apollo engineering group here. I have a few new things to share this morning, but most of what we're announcing over the next day or two is in these talks. So I encourage you to come to as many as you can. If you're here with a group, maybe divide and conquer, but we just have a ton of technical content for you, new products, and lessons that we've learned working with all of you, and many, many more. Okay, that's our program. I have, by far, the most new stuff to talk about that we've ever done at Summit. So I'm just going to jump right in. It's been a great year for GraphQL. I'm just really excited about the tech. I'm an engineer at heart, and I think this is like really cool kit. We have a front row seat to the growth and the momentum. We just crossed an exciting milestone of 25 million downloads a month now for just the open source client and server libraries that Apollo maintains. That's one view on the energy and the excitement. Another measure of progress comes from Postman. So they run an annual survey of their API developer community, and what they reported in their last report is just shy of 30% of API developers now report using GraphQL in their jobs. Yeah. And to me, it's remarkable to see an API technology grow this quickly, right? It's not like a database or a developer tool. You need two people to agree, right, before you can get started. And so for APIs to grow as fast as they have on GraphQL, I just think is really significant. But what's most interesting to me is the progress we've made in the enterprise. And these days the enterprise is the crucible. It's really the environment with the most demanding requirements, whether that's performance or security or any number of other factors. And it's the enterprise technologies that really spread and stick. That's the acid test. of what works. And something truly remarkable has happened over the last year. So earlier this year, Gartner, one of the analyst firms, wrote their first report on GraphQL in the enterprise. And if you're not familiar with Gartner, they're a firm that covers the entirety of the enterprise software stack. They have a large API practice alongside a lot of other areas. And so this is their first take on what's going on with GraphQL. And the punchline is this: over the next 2 to 3 years, their projection is that the majority of enterprises are going to be using GraphQL. And that is a step change. Now, you all know this, right? You all saw it first. But welcome to the future, right? This is what's coming across the board. You see the value of this, and if you read what they wrote, it's not just that it's going to be GraphQL, it's a particular kind of GraphQL. It's the supergraph architecture that we've championed, this layer that we're bringing into the stack. So, it's clear to everyone, I think, now in the industry that GraphQL is a must-do. It's an essential part of the modern stack. And I think it's instructive to ask how that came to be over the last year. What changed, right? Why is that, and why is it happening right now? So part of it is it's people, right? And I wanted to take a moment to acknowledge the people that have really pushed this forward in all of your companies. We run a community of now over 1,600, we call it the Champions community. I think many of you are here. Raise your hand if you're part of the Apollo Champions group. Yeah. Keep your hands up for a second. If you're not in that group, look around and find one of those people. These are the people you want to learn from. This is what I was talking about a minute ago, so thank you. The work you've done to spread GraphQL and make it a success, not just in your own companies, but in the industry, right, is what's really driving a lot of this new momentum and understanding. So that's our achievement together. And when you ask, especially the people who've come to GraphQL more recently, what drove that? Why did you do this? We hear a new set of reasons that are a little different, maybe from what we heard a year or two back. We hear a lot of people talk about wanting to adapt the APIs they have to a new use case. We hear people talking about joining or sequencing API calls. A lot of people want to unify a set of APIs that may be duplicative. They want to harmonize multiple generations of APIs that represent some of the same ideas. You talk about performance a lot, of course, and there's this idea that you want to augment the APIs with new capabilities. Real-time is a good example of this, GraphQL subscriptions on top of the REST APIs that you have. And the common thread, of course, is APIs. We've always had a story for why GraphQL makes sense to the application developer. But what we're starting to see now is that we've cracked the story for why GraphQL makes sense to the API teams. And that's so important. It's a consensus that's emerging. It's what Gartner talks about in their report that we've all understood, which is that GraphQL really is the language of this new layer of the stack, right? The supergraph that orchestrates how your APIs are going to be called. And that's so important. We're not here to displace REST. We're not here to get rid of SOAP. I'm sorry if that was your hope. I think that'll happen, but we're really not here saying that GraphQL is better than the APIs that you've got. It's not better than gRPC. It's not better than REST. That's not the point. It makes those things better, right? And that's the simplest way I can put it. GraphQL makes your APIs better. It lets you do more with them. It lets you get more value from them. So whether you're building a new mobile app or maybe you're working on an LLM and you want to do something meaningful with that LLM, or Maybe you've got an API. Maybe you own a SaaS product, or you've got an internal service, and you want to drive more consumption of that API, or you want to make it more valuable to your users. What GraphQL does for you in all those cases is nothing short of transformative. It's a generational shift in how we write software and what we're able to write because of that. And now that we're not fighting the APIs, now that we're here to help, I think we have an opportunity to really broaden our horizons and think bigger about what we're here to do. And so for us, it's really simple. If you add up the momentum, the consensus, the much clearer path to adoption, particularly at large scale, the proof points of the success that people have had, I think it makes the mission really clear. It is time to bring this technology to every developer at every company, in your companies, but all companies, at all scales. That's our goal. That's what we're here to do. Yeah. And so this morning I want to share what we're doing here at Apollo, some of the things we're doing toward that goal. And I'm going to focus on 3 areas for us. What we're doing to make it easier for developers, what we're doing for the platform operators, and what we're doing for what's next. Okay, let's start with the developers. So I said, the enterprise is the acid test of what technology succeeds and what doesn't, but I think there's another factor that's just as important. And that's how easy it is to get started and how quickly you get to something interesting. There's a lot out there. There's a lot of stuff that we have to think about or use, right? And we don't have a lot of time or patience for things that don't get us to something interesting. And that can come in a lot of forms, right? It might be a concrete value. You might adopt something, be able to put it into production, and you can measure, quantify the value that you're getting. That's one way you can see this. I think sometimes it's more of an architectural or an academic argument where what you've seen earns a level of conviction that a technology is going to serve you well for decades to come. I think Kubernetes is an example of this, right? It just makes sense when you think about how it works and in comparison to what came before. I think sometimes it's more emotional, right? It's one of those moments where you touch a new piece of technology and you just feel like you've seen the future and you don't want to go back, right? You want a job that lets you use that stuff, and you want to. That's the way it's going to be from then on, right? It feels right. There's some joy to it. I think the really good news is GraphQL has all 3 of those in spades. If you think about the first time you write a GraphQL query, it feels great. It feels right. You know it's going to work, right? And it's obvious every time you write that query how much time you're saving, right? Think about what's the cost of writing a handwritten backend for front end, right? All in, it's probably $100,000. If you just add up the total cost of ownership of an API endpoint. So we've got that. But I think there's a hard truth we have to face at the same time, which is it does not come easy. In fact, there's a pretty long fallow period where you don't get anything in GraphQL, right? All that shit you have to do to get middleware working, right? All the stuff you have to connect to and configure and just the fussy integration points. I think you know how hard it can be, right? We all feel it. And it's not just the technical work. It's rolling out a supergraph is like the mother of multi-stakeholder decisions, right? And it can feel like a UN negotiation to get this stuff stood up, right? So we feel that. I think everyone does. And you see it. You see it on Hacker News and Reddit when you see developers talking about this stuff, right? There's this skepticism. Gartner calls it out in their report. I mean, they do this with all new technology, right? It's hard to use. We need to make it easier. But it's true. It's hard. And so, even as they say it's going to grow as quickly as it will in the enterprise, to me, that's really a call to action. We've got to address this if GraphQL is going to be something that we can bring to every developer and that really fulfills the destiny that I think it can. So what can we do about it? Well, if you think about what's actually going on in here, the thing about GraphQL is you're not really anywhere until you can write that query. And it takes a long time before you can write that query, at least on your own APIs, right? It's the server. The server is not remotely easy. And in fact, the closer you look at the whole design, build, operate workflow for building a GraphQL server, the more stuff starts to stick out. Take schema design, for example, right? It's this idea that we're going to do a free-form, demand-oriented schema, something that's going to right all the wrongs of the past, of the mistakes we made in our APIs and the surface area of those APIs, something that's going to accommodate the needs of our user experience today, but also with a thought toward what's going to happen tomorrow, what we might need tomorrow. Something that all of those stakeholders can sign off on. Something that contemplates from the start a federated architecture, which adds a whole other layer of complexity, right? And that's just the schema. Then you've got to pick a language, you've got to design your runbooks and how you're going to build these intricate resolvers, we call them, that go into the server. You've got to think really carefully about performance because you're putting an extra hop into the network, right? So latency of these servers matters. You've got all the stuff that you normally have with deploying a service. And GraphQL actually adds a twist on this because the goal of GraphQL is what you publish into the graph is going to be used by more and more applications. So you end up carrying a pager for other people's apps, right? And either you didn't expect that, and that's no fun, or you did plan for that, and then it kind of cascades all the way back to the start. You take an even more careful, more waterfall, more measure twice, cut once kind of approach to building the server. So, GraphQL servers are going to be important for a very long time. And we're going to continue to make investments in all of these areas. But I think it's really hard. It's really hard to get the quick value that we need from GraphQL if this is the way we're going to do it. And we really need something different. So, the alternative is configuration, right? Something that lets us tell the graph layer how to call the APIs directly. And it's been tried. There are a number of projects and products that offer something like this, but none of them have really gotten mainstream adoption because they haven't really solved for what you need at true scale in the enterprise. And when we look closely at the way that subgraph servers are used today and the APIs that they sit in front of and the patterns that work best in our customers, we think we understand why they haven't worked and what you really need for a declarative approach to succeed. And there's 4 things. The first is you need an explicit schema artifact. Schema is the whole idea behind GraphQL. It's the soul of GraphQL. And so it needs to be something that a developer can design. It needs to have a life cycle. And what won't work is trying to automatically generate that schema, trying to automatically mirror the underlying API's surface area. Down that path, you end up with something that maybe speaks GraphQL technically, but it's not really a super graph. It's not something that really brings you the value of modeling your domains and being able to reuse that in different and unanticipated ways. So we've got to have a source of truth. We have to have a degree of flexibility is the second one, and on multiple levels. We can't make any assumptions about the underlying APIs, right? We cannot assume that there's a Swagger definition. We can't assume that the APIs are going to have a consistent authentication pattern or use the same headers. We can't assume anything about consistent style or object formats in these APIs. Often you're going to have multiple generations. I mean, in a typical enterprise, these APIs span half a dozen presidential administrations, right? Not to mention the third-party APIs that you're using and want to be part of your graph. So we've got to be able to adapt to what's there. And we have to be able to adapt those things to the graph that we have. So we need a flexibility in terms of how to take an API and adapt it for the style of schema that already exists, for what we've already published into the graph. If we don't have that, we don't really have something. So that's the second thing. Of course, you need it to be based on federation, right? That's obvious. With all the same self-service semantics, the query planner, the advanced features that it brings you. And you need to be able to mix and match, right? You're going to need to be able to take a declarative part of the graph and have that coexist seamlessly with the subgraph servers that you've already written or will continue to write that use imperative code to connect your APIs into the graph. That all has to be one and the same. And maybe most importantly, certainly a consequence of the other three, is you need world-class tooling. That's a hallmark of every great declarative architecture, and it's a necessary one, right? If you're not going to write code, then you need to be able to understand what the system is doing. And you need that both at build time and at runtime. And tooling ends up driving a lot of the rest of the design, right? It dictates the character of the configuration language, for example, because you need the tools to be able to work with that. Okay, so that's what you need. Guess what? We have been working on this for a very long time, for years, really going back all the way to the beginning of Federation and a lot of the design decisions that we made in the original design for Federation. And so today I am delighted to be able to share with you Apollo connectors, our new take on GraphQL without the server. It is a completely new approach to GraphQL. It lets you bring any REST API to the graph entirely declaratively in, 2-3 minutes? It doesn't have any complicated schema design. There's no servers. There's no resolvers. There's no data loaders. There's no extra hop in the network. There's no pagers. Nothing but schema and a few new and quite powerful directives and some absolutely wicked tooling. Do you want to see it? Yes. Okay. Let me invite Michael Watson and Trevor Scheer up to the stage, and they're going to show us what we've got.
All right. Okay, so let me set the stage for everyone a little bit. We're going to be building out our new digital e-commerce experience. And one of the things we chose as part of this new effort is we want a new content management system. And so we chose Strapi as our new headless CMS. Now, one of the reasons we chose Strapi was because it provides this nice little REST API for anything we create in it, right? And so we get all of this CRUD operations for these documents. And for our use case, we're putting all of our product images, our product metadata in our content management system. So let's see how easy it is to use Apollo connectors for REST to integrate this new Strapi instance. So the first thing we have to do is we have to write out that schema, right? That's the first step. So we have our product. It's got a name, description, some images. We just have a simple hero and thumbnail image for now. And then, of course, we want to expose the product. We can get it by an ID, and then a list of products. Strapi provides us some nice things with that REST API like pagination, so we just want to put that in there right from the get-go. Now, the next thing we need to do is we need to import the new directives for Apollo connectors for REST. We're going to use the source directive to point at our Strapi instance. This has things like the URL and other requirements like the authorization header, for example. And now that we have that, we just need to connect our root entry points using that connect directive. So first, we're going to say @connect, and we're going to point at that Strapi source. Now, you notice all those little red squiggles? This is what I'm really excited about, that tooling. So we've actually integrated the Apollo language server, which is new, into our VS Code extension, so we can get that validation right here in line. And then, if we fix that error and add our selection set, whoops, I got one hand, you know. And we add the selection set, that error goes away. Now, I just want to take a moment to pause here. This is actually a full connector that we're seeing on the screen. And let's take a moment to look at it. So we have our product by ID, which was just the GraphQL portion. We're actually taking that argument and we're putting that along into that URL that's being sent as that GET request. This little selection, this is actually the JSON that we're selecting from the REST API, right? And what I really love about this is no matter how complex that data source is, I can express it in the schema that I want to. Now that we've done that, let's actually connect our products. So we'll come in here, and we're going to add basically another connect that looks pretty much exactly the same. The only difference here is we're providing that start and limit for those pagination into that same URL. And that's it. Just a little bit of schema, no code, and we just wrote our first connector. So now we're ready to test things out. And the easiest way to test this out is using Rover Dev. And what Rover Dev does is it provides us a nice little sandbox environment where we can open this up and we can start writing out some operations, right? I can come in here, let's just add the name. We got some data back from our Strappy instance. And we can keep building this out. You know, if I want to add in that pagination and say, well, you know, there's 3 here, let's just take 2. It works, I can add in those images, you know. And the best part about this is just GraphQL, right? I'm just writing out the operations of what I'd expect. But just like when you're writing those connectors and you see what's going on, we also need to know, like, how is this actually executing under the hood? And what I think is really important is actually being able to see this real time. So we created the connectors debugger for that reason. And this really allows us to see what is happening under the hood. So we can see the URL, you can see it's going to my Strappy production hosted in Railway, you can see the parameters in there. And more specifically, what I love to see is actually what is the API response? This is that complexity coming from Strappy. They have this whole thing with like attributes and data pattern, but none of that matters in my schema, right? Very powerful stuff. And then finally, what is the mapping that the Apollo router would be applying to that JSON selection? So I can kind of see all the pieces that are going on inside of there. Right? And in just a couple minutes, we just built our first connector and we just connected to a production CMS instance, right? I think that's a clap. So cool, we got one thing, but you know, when you start thinking about the tools you use, we chose Strappy because it gave us that REST API. We probably chose other tools for similar reasons. Like, we want to add our pricing information now. Our checkout and everything is actually all in Stripe, right? So all our pricing information, our payments, all of that. But the interesting detail here, Stripe has the concept of a product too. And inside of that product, you know, price just isn't a number. It's actually an object, right? And when we look at that object, the price has other details around it. You know, is it a reoccurring payment? Are there multiple payments, one time? All of these details. And that's one of the reasons we chose Stripe, because it takes care of all that for us. So let's see what it would look like to actually put the price field from our Stripe instance into our Strappy. So we'll head back over to VS Code. Let me make some room for us. All right, so the first thing we need to do is we need to use that source directive. But this time, we're now going to point at Stripe. We're going to have all of the Stripe parameters. Stripe's got some differences, you know, a content type, it's different, a version, but easy for us to handle. Next, we're going to define out our price, right? For our simple use case, we're just going to have the unit amount, the currency, and whether it's active. That's what we're going to pull from Stripe. Now, where it gets really interesting is when we want to add that price field to our product, right? And this is where we saw that ID field coming back from the price. So when we do this connect, we're actually going to be connecting the price's ID in our schema to that Stripe ID, which was that default price. And now when anyone else requests, oops, you know, one hand with my shortcuts. Oh. There. And now that we have our price ID mapped up, we need to just expose the other fields for our price, which is that price route in Stripe. And here we go. So what we're actually doing here is we're just now going and providing the ID of that price field to the prices endpoint for Stripe. And this actually connects all the pieces for us. Now, I just saved the file in the background, so rover dev hot reloaded. We can head back over to our sandbox environment, and we should be able to see that new price field. Let's just request the unit amount for now. And there we go. Uh-oh. Okay, so the price didn't show up. And sometimes this happens when we develop things, right? And we need to figure out, like, oh, what went wrong? So let's look at that connectors debugger. I see a little red X here. Let's click into that. I see property unit amount not found in object. Okay, well, if I look at the response, it's actually unit amount. So I just had a little typo in here. You know, that happens. But I'm developing. I'm in my safe space on my machine. And then if I come in, rerun that same query, right? Rover dev hot load and the background, everything, and we should see some pricing data pop up. So pretty awesome, right? We just connected like legit production Strappy instance, production Stripe in what, just a couple minutes. And the best part is this is all built on federation, right? So all those rich details of that execution also comes through in the query plan, right? So I can actually see what is that waterfall of requests from our Strappy instance to our products, to our Stripe instance with our products, which gets flattened out, to our Stripe with our prices. So the full stack, I can see it all right there. And it is built on federation, it's built on the router, so we can also take advantage of all those advanced router features right away. Like, I know my Stripe pricing information is always coming back slower than my CMS. We got CDN, all this other stuff we've put behind it. So I should be able to just, select my price, extract it to defer, and let the router handle that execution for me, right? And so now we have a deferred query plan. We didn't do anything, right? It's amazing. And to show how amazing that is, if you actually look at the response, you can see that first chunk, 293 milliseconds versus 691 milliseconds. So that time to interaction for our users is faster. We didn't write any code to do any of that, right? Now, I'm so excited to see what you all build with the connectors, but there's a lot more in that tooling behind the scenes. So I'm going to bring my buddy Trevor up to show you all about the tooling.
Nice job, nailed it. Hey everyone, I'm really excited to be here to show you what the tooling team has been working on. We built a language server for federation with federation awareness, and it understands your supergraph. If you're not familiar with what a language server is, it's basically the underlying tech that powers your editor and all of the features that you love to use in it. Our language server is built in Rust on Apollo's modern GraphQL tooling, so it's fast and it runs anywhere. We just got to see it running in Watson's demo in the VS Code extension, but we also have it running in the browser in our proposals editor. So we're going to go ahead and take a look at a proposal that I'm working on right now. If you're not familiar with proposals, this is how we collaborate on schema design in GraphOS. So I've got the ability to edit some of my subgraphs here. We can see them all over here. Now the number one value add here from the language server is going to be the inline errors. So we'll start by introducing an error, and we'll go from there. So right off the bat, I've got a composition error. And this is letting me know that my ID field is incompatible across my subgraphs. We can even see on the left over here, I've introduced a few errors that, I wasn't even in my coffees or my orders subgraph, and I've got errors over there. We can jump over to those errors and see that my ID field is actually an ID type. So I should go ahead and change that back and get in line. This is already a huge improvement over our subgraph DX today, but the connectors team has been hard at work making sure they have validations just like this. So we'll take a look at a few of those in my connectors subgraph. We've got a hint to get us started. This is letting me know that my federation version is being auto-upgraded from version 2.8 to 2.10. So we can go ahead and just take that upgrade, and we're all set there. On the source directive, we've got validations on the name to make sure that you're referencing valid sources. All of my connect directives that reference this coffee source are invalid because I changed the name. So if I go ahead and change that back, we'll see those errors clear up for us. We've got some awesome validations on the selections themselves. So if you go ahead and add a new field to the coffee type, we'll see I've got an error here letting me know that this field needs to be resolved somehow. I either need to add a connect directive to it, or I need to go ahead and add it to one of my selections. So I'll go ahead and add it right here. And we'll see that error clears up for us. If I go to change the name of one of these fields, I'm going to get errors everywhere that they're referenced. So this temperature field is now invalid. And I'll go ahead and change that back. Now, if you're familiar with language servers, you know that they're capable of a lot more than just the red squigglies. So I'm going to show you a couple of those features as well. We have lots of information on hover. So all of your directive definitions and type definitions have information when you hover over them. Our federation directives are pretty well documented now.
Yeah! Yeah!
So we've got a rich description here telling you how to use the directive with the definition there letting you know what arguments are available to you. We also have a link right to the docs, so you can get a reference there. And your types get the same treatment. So if you go to the link to document your types well and use good definitions, we'll render that in full markdown for you. You can add links or anything, any kind of styling you like there and show you the definition in the subgraph.
Yeah!
It gets a lot better. So we've got auto-completion all over the place. If you tend to forget all of the federation directives like I do, all you have to do is press the @ key and we'll show you all of the directives that you can use in that location. You might see some of these say import from federation here, and that's because I haven't added those to my import list. But we'll go ahead and take care of that for you. As soon as I take that auto-completion, I've added it to the list automatically. And in case you missed it, just watch that list, the import list up at the top. Pretty slick. We have some powerful snippets for our directives. So this connect directive is pretty verbose. There's a lot to know. And I'm just going to comment this out so we can see what this snippet looks like in action. When I take this completion, it's going to populate all the boilerplate for me. And now all I have to do is fill in the bits that are relevant to my connector. Oops. And we're all set. And like any good JavaScript developer, I put the $sign on the outside of the brackets. So we've got a validation for that. And now we're all set. So I want to give you just a taste of what it means for your tools to understand your supergraph. So when I go ahead and command click my coffee entity, which I have defined in all 3 of my subgraphs, we're going to get one that I've always wanted, and that's jump to definition for entity. So this peek window that's opened up is going to show me everywhere that my coffee entity is defined. I can take a look at those definitions, and I can jump over to one if I need to make some changes in this order subgraph. It's pretty sweet. Now, I want you to try to just imagine what else this editor might be capable of when your tools understand your supergraph. And I want you to come to my talk tomorrow, and I'll show you what those things are.
Yes.
That's it.
Let's go, man. Thanks.
It's so easy you can do it with one hand. I think that's our new tagline. Thank you, Watson and Trevor. This is fantastic. This is the GraphQL we always wanted, and I hope that's coming through here for you. There's no server, there's no code, there's no network hop. It's 100% federation, right? So it's going to work. It's going to scale. This is not a toy or a prototyping tool. As they both said, it's just the tip of the iceberg. There's a keynote tomorrow morning where we're going to get into a lot more depth. There's an entire language inside that selection set syntax that you saw. We can do transforms and functions and computation. There's tooling that you're going to see tomorrow as well. Just think about what this really means. right? You're not limited now to putting just the most important APIs into your graph, gated by the capacity you've got of these subgraph development teams in your sprints, right? You can just put everything in the graph. There's no time investment. It takes 5 minutes, and anyone can do it. So the API owner can write the connector. An app developer can write a connector that allows them to write the query they want. A platform team can write a connector to bootstrap the graph, right, and show off what's possible. It really changes the situation. It's night and day. And so our recommendation is try it out. The next thing you're bringing to the graph, use connectors. Now, it's not going to work in every case. You may find that you still need, in some situations, the greater flexibility that handwritten code can provide you in GraphQL servers. But our mission is to close that gap as quickly as we can. And I think you're going to find that connectors really changes the perspective of what GraphQL is for you and for your teams. It's the biggest thing we've ever shipped, and I'm so excited for it. All right. That gets us to part 2. There's another reason we built connectors, and it has to do with how we can make GraphQL easier for the platform engineering teams that are running these things at true scale in the most critical settings. And so before I get to the announcements here, permit me a moment, because I want to talk about how we're thinking about GraphQL in the context of the broader world of platform engineering. So here's the strategy. Our goal is to build a whole API platform around GraphQL, right? Again, GraphQL is not a replacement for REST or some other API. It's just simply the language of the platform, its instruction set. And the platform's job is about how you orchestrate the calls into all those APIs that you have. And we've been working on this since the beginning, right? The core GraphQL language gives us self-service queries for the application developers. So every time you're writing a query, you're not writing a new API endpoint. You don't have to wait on some other team to write that API endpoint for you. And so that was our first focus, building the Apollo client libraries and the tools that really help with query authoring and management and understanding queries. Then we have federation, right, which makes publishing schema into the graph self-service. You don't have to block on adjacent teams. You're not all stuck coordinating in a monolithic GraphQL server. So that's self-service at that level. And now, of course, we have connectors, right, which is what completes the story. It's self-service for the schema. It lets anyone bring the APIs they want to the graph. Again, without blocking, without asking somebody else to do the work for them, without coordination. And that makes the whole thing self-service. And that's what we really wanted and why it's the right time to do connectors now, because now we can think about Apollo the way we think about other declarative technologies in the stack. Like Kubernetes, right? Let's look at the modern cloud-native stack, right? And we start with containers. I think that's a given now, and all the networking machinery that containers makes possible. So there's a new sort of foundation or a starting point if we think about a modern cloud-native approach. There's a lot we can build on top of that. Databases, for example. There's a new generation of cloud-native databases. One of the big ideas here is the container piece of the puzzle lets us think about databases a new way, where we can separate compute and storage. And this, of course, allows us to operate at tremendous scale and in a self-service way. We have a whole world now of essential capabilities that we can bring into our cloud-native stack. So services that handle key management, observability, and so on, right? And then you've got a generation of tools, Backstage, Argo, for example, that we can use to manage all of this and manage both these services and the services that you write. You can kind of see the wavefront of platform. Is platformization a word? Yeah, the wavefront of platformization moving across, right? Each of these changes we're abandoning the handwritten, intricate, in-house code we used to have to write in favor of reusable systems and infrastructure. And there's two big advantages there, right? One of them is I don't have to write that stuff anymore, so we get valuable time back. But the other is leverage. The stuff I do write, the unique stuff for my business, the services I need to build, we're building on higher and higher tiers of abstraction so we can get more done more quickly. That's why we have microservices, right? It's pretty easy to write one now. And so the question is, what's coming next? What's the next thing that gets platformized? It's APIs, right? Specifically, it's how we package and orchestrate the API calls into all of this stuff and everything that we're building on this stack. It's analogous to how Docker and Kubernetes package and orchestrate software. And the idea that we're going to do that with handwritten code, I mean, it's nonsense. It's like scripting software deployment. So to me, it's obvious that it's going to be GraphQL here. Federated GraphQL specifically. It's the consensus, standards-based approach to API orchestration. And I want to talk for a minute about federated GraphQL. That Gartner report I mentioned earlier, that says GraphQL is going to be in the majority of the enterprise. Here's the other big take in that report. Federated GraphQL is going to grow a bit north of 10x over the next 2 to 3 years. It's going to go from less than 5% of enterprise deployments of GraphQL today to about 30% in their view. So today I can say that federation is simply the standard. It's also gained interest and traction among the community of folks building GraphQL tools and who contribute to the GraphQL language specification. And we've been putting a lot of work behind the scenes into making that happen. It's the old saying, if you want to go fast, go alone. If you want to go far, go together. We're done with the alone part. It's time to go far. So I'm delighted to share that a joint effort is now well underway to define an official federation standard under the roof of the GraphQL Foundation. We are leading that effort along with other members of the foundation and its technical steering committee. The plan we've agreed to codifies all the core parts of federation as it works today, and that you know. It'll be 100% compatible with the Apollo Federation that you're using in production. There's no breaking changes to that. It's also going to include some new ideas we're working on that I'm really excited about. You're going to hear about some of that in the conference that you can adopt incrementally. And look, our view on standards is this. We need to bring GraphQL everywhere. And we now have enough real-world experience with federation to be confident that we got the core design right. So that makes it the right time to codify as a shared standard. We have such a deep commitment to standards because we know you do too. Good standards are so valuable. They create confidence. They let us make safe and decisive decisions, right? They're a strong signal of the technologies that are going to have a vibrant level of investment for years and years to come. They give us choice and interoperability, and they grow the market, right? Look, our goal is not to lock people into proprietary technology. That would be tremendously short-sighted. It's what I said earlier. It's to bring this stuff to everyone. So that's going to be great for all of us because good standards catalyze enormous ecosystems. And for me, there's no ecosystem more interesting right now than the cloud-native movement led by the CNCF, which Apollo joined formally earlier this year. We're excited to build more bridges and partnerships with everything you see here and more, and participate in even more communities. It's all part of being on an open platform. Open standards and open platforms are the key to true scale. And here's someone who really understands platforms at scale. We've been working with Yogesh and his team at CVS Health to bring the graph to every developer there. And I'd love to invite him up now to talk about what they're doing. Welcome.
Thank you. Exciting announcements.
Thank you. Tell us about GraphQL at CVS.
Well, I will start with the API, how we have been.
Yeah.
As always, every tool comes with two things. We can build software faster. We will bring consistency to the consumer, to the colleagues, to the development community. I'll say them coders, I can say them engineers. So that's what our journey has been with overall APIs. And definitely few of the things, doing faster development, that has been a part all of us are able to achieve. But there are challenges. There are challenges like this music. But over the time, as company grows and everything happens, there are things. You see the duplication, you see discoverability to be the challenge, and leads to the inconsistency. That's where I think the CVS journey has been. We have gained some things, we have lost some things, so that's what I will say our challenges has been.
And how has adopting a GraphQL API platform changed the way you think about that?
See, if you talked about schema, you talked about those. The first and foremost, I believe, is about discoverability. Are you able to do discovery? Then you will not build duplicates. No developers want to go and build the repetitive tasks. Everybody wants to do something cool. So that's the first thing. Having a standardization always and a discoverability takes things away. Then second is no one wants to do repetitive tasks. We all are here to build something unique. All as a company, everybody wants to do something unique and build something innovative. So that goes away. Last but not the least, the performance, instrumentation, tooling, all those things which comes out of the box, that makes life for developers way more easier. That's how I see it.
A lot of that's really about people and culture. Engineers have a choice in what they work on and where they work and what they want to build. Let's talk about that for a minute. You have an interesting saying about the 3 C's that you were telling me. Tell me more about that.
See, it's an interesting thing. 3 C's for me is consumer, colleagues, and coders. And this community, I call them engineers and coders. Important piece here is the culture is, for this group, for all of you to know, the best ideas always come from the engineers. That's the point taken. So engineers are the people who bring the best ideas.
Yeah.
And when can engineers actually solve the business problem? When they have a time to think. When they have a time to sit and solve the problem, not take the orders from the people and build something. And what overall cultural shift which we are able to do with all these changes which we are talking about is about that mind shift. That now our engineers are actually focused more on solving the problems, which is not a repetitive task. I'll give an example, which my team is anyway going to present, is like, we wanted to write queries automatically. We don't want any human to even write a GraphQL queries. So my team went and solved that problem by using LLM instead of even writing those. And that time we got because we have removed that redundancy from the system. We have removed that kind of a repetitive task from a developer's mind. So that's how I see, and overall results have been very impressive. The APIs, which used to take thousands of lines and 5 to 6 weeks for us to develop, now it's like hours. It takes hours for us to build it. And all of us have been talking about LLM a lot. LLMs are not going to solve a problem. End of the day, those schemas which you design, the semantics you design, and your ability to bring all that data together and then use LLMs on top of it, that's what will make a difference. So that's the power of what we are doing.
What's next at CVS? What's the platform going to unlock?
I think the most important thing, I'll say experimentation.
Yeah.
As I said, we have been able to move from weeks worth of development to hours of development. That means more experiments. I go back to 1970s. 1970s, to do an experiment is like $1 million or $5 million thing. And the success rate has not changed from last 40, 50 years. You do more experiments, it's only going to, the percentage of success rate is still same. So we are able to do more experiments because the cost of experimentation has reduced. So I think that's the thing. Our engineers will do more experimentations, help our business to think differently. I will say at this point, we are at a point, earlier we used to talk about a backlog and everything. Now we talk about, hey, what can we think together? That's a change what's next, which is coming out.
Yeah. If you are looking for how can you help persuade your leadership to do this at scale, Yogesh has amazing insight into this. It's been a joy to work with you together, and I'm so excited for all the big things you do.
I'll say one thing. When looking into the investment piece of how it takes time, people need to spend that time.
Yeah.
If you don't spend that time, you will not get the ROI. You will go into that sweet spot where it's important.
Thank you.
Nice. Thank you.
It's such a cool technology when it's got visibility really high up into the organization. There's a story you can tell about Graph that resonates with company leadership that doesn't give a damn about the technology, but they understand what it means to be able to experiment, to go from a backlog to a what are we doing next? We have a bunch of stuff I want to share on the platform front. So these are things that we've done for the platform operators that allow you to do Graph at extraordinary scale. First one is something we announced earlier this summer called entity caching. It's a mechanism for caching data inside the Graph. And the reason for this is that GraphQL actually creates a challenge for platform operators because it breaks the normal HTTP caching model. The problem is basically builders want to write queries that mix and match lots of different APIs, right? Like what you see here. And you can always cache the output of a query. A lot of people do that. But workloads like this, where you've got novel combinations of different things, right? Or where some of what's in the query is uncacheable, makes that a less helpful solution. So what we've done is something different. We call it entity caching, and it integrates caching into the Graph itself and addresses the fuller spectrum of what operators need. Dow Jones put this into production earlier in this year. This is the Graph that powers the Wall Street Journal app and the website. They saw two big benefits. So of course, improved response time. That's what you'd expect. But the one that's really interesting to me is this decrease in load that they saw on some of their services. And this is huge because if you write a query that's slow, you're probably going to notice. You're probably going to do something about it. But in GraphQL, it's really easy in this self-service world to write a query that adds load to a service that you don't know about. That's kind of the whole idea, right? It's this abstraction so that you don't have to understand the services. So caching ends up being an essential capability of a platform like this because it defends the property of self-service. It lets the platform organization provide reasonable workloads onto their API users and still offer that self-service capability for the application developer. Here's how it works in a little bit more detail. Federation lets us think in terms of entities. And so in this example, we've got a product that's been built up, and we can segment those entities by the subgraph that provides the particular fields, and that fragment is the unit of cacheability in the graph. We can put a TTL on that, right? So in this example, we've got a TTL on pricing fragments, and we can do that manually, or we can respect the underlying cache control headers from the pricing API. And so when we execute a query, we can check the cache. This is all built into the execution machinery, and so we can fetch that fragment out of the cache rather than doing the upstream query to the API. Sometimes TTLs aren't good enough, right? And so here, if you change the price of a product, you may reasonably need that change to show up immediately. We actually have customers where if you put an old price on the screen, there's a regulatory commitment to honor that price. And so what we're adding today is invalidations. Invalidations let you programmatically expire these individual fragments. It's really simple. It's just an HTTP post to a router endpoint. And you can post that from anywhere. You can post that from your subgraph server. You can post that from your underlying microservice, source of truth, database trigger, a Kafka topic, whatever makes sense for you. And when you do that, of course, the next request refetches from the origin, repopulates the cache, and off you go. So it's a great pattern that we're excited about. Number 2 we're introducing today is demand control. This is another tool for platform operators to monitor and limit the use of upstream APIs. Everything in the graph is backed by services. And services can have very different capacities or costs. You may have third-party APIs in your graph that have strict limits on how much you call. There may actually be a monetary cost to calling those APIs, right? If you think about the LLM providers, for example. Conversely, you may have third-party users of your graph where you want to give them the flexibility to write any query they want, but where you can't necessarily limit or approve individual queries the way you can in a first-party setting. So here's the code. It's really simple. We add this first-class notion of cost to the graph. It's a property. And based on that, we can either compute an estimated cost before we run the query, or we can compute an actual cost after running the query. It's a bit like the difference between explain and explain analyze, if you're familiar with SQL query planners. And you can do a few different things with costs today. You can limit operations based on total cost. So this is sort of a more sophisticated form of height or depth limits that we've got today. But the other thing you can do is you can propagate all of that cost information through the rest of the stack. There's a deep integration that we've built with our OTel layer. And so, for example, you can plumb costs into your observability and monitoring tools that you're using. And there's a lot that we'll be doing on top of that over the months to come. Okay. So I have one more thing on this front, on the platform front, and it's a little bittersweet because I have to say goodbye to something that served us for, 5 years now. And that's our original JavaScript query planner. So it's a new beginning. The third thing we're announcing today is a complete ground-up rewrite of the query planner inside Apollo Router. Yeah. Thank you, JavaScript. You served us well. I've talked about query planning a fair bit. You saw query plans earlier when Watson was doing the connectors demo. Just to remind you what it is, this is the computer science inside the router that turns a query like we have on the left into a execution plan like we have on the right. You can think of it as like the brain or the air traffic controller in the router. So a little bit about how we got here. As Federation gained momentum, we knew we needed a scalable and secure and performant and efficient runtime. So that's what led us to building Apollo Router. And Router is written in Rust because there's no better language for performance-critical infrastructure. But for expediency, we kept the JavaScript query planner because query planning isn't in the hot path of every request. Makes sense. But now, we have customers running thousands of routers in their fleets. We've got supergraphs that have north of 100,000 unique operations that are in flight at any given time. So you can cache query plans, but at these scales, query planning time does matter. And so now it's time. Here's what we've got. All new code, natively written in Rust. That's much faster. Native also means we can do real multi-threading finally. That's very difficult to do in the JavaScript environment. Even more, much faster. One thing that hasn't changed is the algorithm. So this is a faithful re-implementation of the existing query planner and its semantics. And to ensure compatibility, we've actually been running this native query planner in production environments in what we call a validation mode. And what it's doing is it's sampling the occasional operations so that we don't create a performance overhead, and just validating that the two query plans are identical. So we have very good data based on real workloads that these two are equivalent, and that the native query planner can be a drop-in replacement for you. There's a small asterisk. There are a few areas where the Rust planner orders fetches in a different way than the JavaScript planner. Now, they're both correct, but we actually like the native query planners query plans better, so we're going to keep those. You'll see a slight difference there sometimes. And there's one feature that we don't yet have in the native query planner, which is support for context. This will be coming very soon, but we didn't want to wait to get it into your hands. It is fast. So, let's start with the micro benchmark. So this is benchmarking the median execution time of the query planner. How long does it take to go from a query to the plan? And this is the median time measured on 200 some odd different representative workloads. We see north of 10x improvement on average across all of that. Now, our goal here is we never want to have to think about query planning time again, even in the most complex environments. Every environment's going to be different. So at Apollo, our own supergraph, the improvement is 15x. We've got some customers that are north of 20. There's some other workloads that are less than 10x. So we really want you to try this in your own environment. And if you see something unexpected, probably not in the output of the query plan, but if you see performance that you're not expecting, Apollo operators are standing by. Here's another benchmark. So now we're looking at overall query execution performance and the whole of routing. We call this our composite stress test. This one's modeled on about half a dozen particularly gnarly workloads in the field. And the big benefit here comes from multi-threading and being able to drop the dependency on JavaScript, the overhead that JavaScript added to the router. So there's a much improved execution latency for the request. That's the leftmost graph. But the big news is the improvement in both CPU and memory consumption of your router fleet. These are really compelling results. So we want you to try this, and we're making it very easy for you to do that. The new query planner is available in the router side by side with the legacy query planner. By default, it runs in that validation mode that I described, so you can ensure that there's no inconsistency in your workload. But it's very, very easy to switch over, and I expect many of you will. And let me be clear. We've gone full native in the router now. No more JavaScript. But that doesn't mean you need to write Rust. You can extend the router in the programming language that makes sense for you and use those extensions to integrate router into your own environment and for your own needs. Okay. So that's chapter 2, platforms. One more thing here. Platforms don't just make it easy to do the jobs today. They make tomorrow easier too. And so what I want to end on is what we're doing to make it easier to build what's coming next. And engineering is a really tough gig. There's this constant tension, right, that we face as engineers, because on the one hand, you're under enormous pressure to ship. The whole business is on the line with this stuff. I mean, you heard Yogesh talk about what they're doing at CVS Health. That's an example that I think is common across all these companies. But if you ship the quick and dirty way, and it is very tempting to ship the quick and dirty way, you're building up layers and layers of brittle software, and you're mortgaging the future. A true platform is the way through. It lets us have our cake and eat it too. It's flexible and it anticipates the future, and it enables you when you get there. And so when something new shows up that we didn't design our APIs for, we're ready for it. Well, the new thing is here. It's Gen AI. And, whether you're an AI skeptic who was hoping maybe this would be a safe space for a couple days and we didn't have to talk about AI, I hear you. Or maybe you're really enthusiastic and you're actually trying to figure out how the hell do I work on the cool AI stuff. Look, there's just no avoiding it, right? There's no engineering team in the world that hasn't been asked, how are you going to do Gen AI safely and efficiently? We all know the risks and the benefits, so let's just talk about it specifically with respect to our role. And I think a couple years into it, one thing's really clear, which is that the prize is not AI by itself, but AI that's baked in deeply to user experience. Maybe a normal way to say it is AI that does something useful for the user, right? And so what we're really talking about is another kind of app that has more free-form nature to it. It has probably a natural language interface, more of a real-time element. It's a hyper-personalized experience. That's what AI really does for us. And so the big open question for us, I think for the industry, is what's the stack going to look like? How do we build this stuff? How do we integrate and orchestrate Gen AI with all the other stuff in the stack that these applications use? How do you build enterprise-grade stuff? But also, how do you experiment quickly with AI? Because we're still hunting, I think most of us at least, are still hunting for what the real AI-driven products are going to look like. So one of the companies that's been thinking most about these questions is MongoDB. We have been friends and admirers for a long time. They're one of the great modern cloud companies that really understands developers and developer experience. And I'd like to welcome now onto the stage Ben Flast, who's going to tell us about Mongo's work on AI.
Hi, everyone. Thanks, Matt, and thanks for having me here. So first, I just want to kind of quickly talk about Gen AI, right? I know everybody's hearing it, you're probably hearing it quite a bit, right? But at MongoDB, we really do believe there is an opportunity for a new generation of applications, right? And at MongoDB, I focus on things related to search and vector search and AI. And so what we think is really important is what are the tools that are going to help you unlock the ability to innovate and use this new technology in a safe and predictive way, right? We're entering this new period where these LLMs are growing by leaps and bounds, right? Orders of magnitude increases in the number of parameters in a model in just the time of a year. And this is leading to a greatly expanded set of capabilities for these models, which mean they're becoming more relevant for more workloads and more applications. And we're seeing, a huge amount of adoption, right? Over 80% of enterprises are saying that they are either testing now or will be bringing apps into production that are using these Gen AI capabilities by 2026. And this is happening across Fortune 500s and startups alike. With that said, what we're primarily seeing, right, are the more safe use cases happening today. And that includes things like chatbots, knowledge assistants, code assistants, and knowledge management, right? These are finding good fit, and people are comfortable with what they're doing, and for the most part, they're good today. But rapidly, we're already seeing people start to push the boundaries of where they bring these apps into production and what kind of capabilities they're building using generative AI. And that's where business context and business logic, as well as more consistency, is required. And that's where we enter retrieval augmented generation, right? And so for those of you who aren't yet familiar, Retrieval augmented generation, or RAG, is a technique for bringing context into these applications and helping prompts for large language models be more consistent and focused, right? And the way that it works is you take some sort of retrieval mechanism, whether that's a database query or some vector search query, and you go and fetch the relevant logic and you bring it into the model to ground the results that it's going to prompt. And this is helping with applications, across the board, including chatbots and others that I already mentioned, but just making them more reliable and consistent. And so to give you an example or two, right, if you can imagine kind of an insurance chatbot or an insurance agent, a digital one, right, that is tasked with kind of giving its customers insight into whether or not it's covered on some injury they've received, right? The first thing that it might need to do is figure out what plan that customer has. So they'll run some sort of standard database query and go figure out what plan this user has. Then they need to go figure out what part of their policy covers this or not. And so at that point, maybe they use vector search to go and retrieve that underlying information. And then they take both of those pieces of information, they send them into the large language model and ask the user to, ask the large language model to tell the user whether or not they're covered. And what's really amazing about this technique is when you do that, you can then also have the large language model cite its sources and provide back guidance saying, yes, you're covered for that broken leg, and here's the part of your policy that says that you're covered, because that's what really matters at the end of the day, the actual policy. Another example would be, vector search for an e-commerce platform, right? If you can understand the intent of a user's query through semantic querying inside of vector search, then you can give better results to the end user and drive higher conversion for searches on your platform. And then finally, if you think about kind of a real-time financial services platform that needs to respond to reports or news articles that are being generated about investments that have been made, you would need to bring in real-time information and send it into these models so that it could respond to the user and provide guidance on data that's happening right now. All of these use cases and capabilities are not possible without having this type of real-time interaction and real-time data flowing into these models. And these are just a few of the possibilities that we're seeing move into production today that all require this type of data. But what's actually crucial when you think about these types of use cases is that they're evolving fast. The models are changing, like we talked about. The use cases are failing or succeeding. Experiments are happening constantly. And what you need to be able to do is change your underlying components at that point. And that's where MongoDB and Apollo really come into play. With MongoDB, you have a fully featured platform that gives you real-time transactional queries and vector search in a single endpoint. And with Apollo, you have an API layer that gives you total flexibility to switch out the underlying primitives as these things evolve. And with these two technologies together, we're looking out onto a whole range of capabilities and new applications that are going to be brought into production. And we're fully confident that taking these tools together is going to give you the flexibility as a developer to build the next generation of applications. And so I just want to thank you again for having me and thank Matt, and look forward to speaking with the rest of you during the conference.
Thanks, Ben. And we're going to show you now the first step in that direction. It's a little crazy, though, so I need you to come along with me for a second, or the demo won't make any sense. Here's the big idea. Your AI is going to have to call APIs. Are you good with that? Okay. Look, there's a set of things that you can't do without calling an API. I mean, obviously, if you want to do a transaction, if you want to order a product, that's one example. But APIs are where so much of the business logic really lives. Think about a retail experience that just shows on the product page when that product might arrive on your doorstep. Table stakes. You're probably not going to buy from the website that doesn't have that. Well, all of the things involved there, right? What warehouse is the product in stock in? What shipping companies do I have partnerships with? And what's it going to cost, and how long is it going to take them to ship that product to the zip code of the user? There's a business decision somewhere in there, balancing how quickly do I want to get the product to the user versus how do I want to optimize for my unit costs as a retailer, right? It probably depends on who the user is. Are they a member of a frequent buyer program or a loyalty member? Maybe you actually want to give the better experience to the new user who's not, right? So there's all of these API calls that have to get orchestrated together just to get that one little thing on the bottom of the screen, which is vital if you're going to be a modern, successful retailer. And you can think of so many examples. You guys know this stuff, right? You build this every day. And the idea that when you go off to build an AI-enabled retail experience or any experience that needs information coming from APIs, are we going to build a custom AI backend for that experience? I don't think so, right? We can't afford the time. We can't experiment that way. And we already have a better solution, of course, which is the graph. You can't call the APIs directly from your AI. You're not going to trust the AI to do that, and that's completely insecure, right? It's graph that's the ideal place to do it. It's semantic. It's declarative. So we've got all the tools we need to give the AI the hints and the hooks to be able to translate that intent that Ben talked about into the result that we want. And it stays agile and experimental and safe. So the last thing we're sharing is a new architecture for how to build LLMs and LLM-powered applications on top of a graph, along with an open source template that you can use to get started with it. And there's two basic ideas in the architecture. The first is that we're going to use the graph for the orchestration, right? So the LLM's job is to translate the user's natural language request into a GraphQL query, right, that expresses the intent of what that user wanted to do. And the graph's job is to execute that query, right, to orchestrate the right API calls and to enforce the security and the rules that we want to impose on that request. Where do the queries come from? That's the second part. In this architecture, the chatbot is only allowed to select from a library of safe queries that we've pre-written. And we load those queries into a vector database like Mongo and do what we call a similarity search. That's just a fancy way of saying the LLM picks from that library of queries the one that's most relevant to what the user is asking for and takes the context from the user, the name of the thing they're talking about or whatever else it would be, and translate those into the arguments for that query. So if you're familiar with functions, LLM functions and plugins, you can think of this as like a smart function factory. You don't have to write code every time you want to give the LLM new capabilities. You just write a query. And that means it's safe, and it means it's agile. So I want to show that to you. Let me bring Michael Watson back on stage once more to take a look at how this works.
All right. Okay, so to set the stage a little bit, that graph we were building earlier, it's in production, right? Someone's put it out there. We're now going to be building a little chat experience for our new digital e-commerce experience. So what I have is we're going to be using the MongoDB chatbot framework. This is just giving us some nice to haves, right? It's going to give us a little vector store. It's going to give us a little chat UI that we have on the left side. On the right side, I just have the dev command for that chatbot framework working. And, just to show you, if I went and asked like a question of like, what products do you sell? Doesn't know anything about products yet, okay? All right, so now we want to start building functionality. And the way we're going to do this, we're not going to actually write any code for our chatbot. We're actually going to do this in the form of authoring a persisted query, and we're going to register that. And what's really nice about this is even if the LLM did create some random thing, we know that everything is locked down to that safe list. So the first thing we're going to do is we're going to author some operations. So as a client developer, I already have my VS Code extension wired up to that graph that we put into GraphOS. And this lets us do things like, let's first build our all products query. Okay. And what's nice about this is when we, write out our query, get all that type completion, right? So if you're thinking like, all right, I'm building out this chat experience, if you were writing all this code, these functions, anything, this is better just in general. I don't have to tell you all that because you know that. This is why we did GraphQL and web, right? But as we start to build this out, we write in our details of the operation we want, product, name, those images. And then what's really nice about GraphQL is we can also do things like adding a comment, right? The operation name we provide. These are all opportunities for us to provide more rich context to LLMs. The way I kind of think of LLM is it's kind of just this person I'm training. And part of my training is I'm naming my operations. I'm giving it that rich context. So I'm going to save that file. And we're going to run this command. What this is going to do is it's going to create an operation manifest. We'll just look at that real quick just so you can see. What an operation manifest contains is it contains an ID, which is the hash of that operation body. Then you can see here's just the body content. And what we're doing is we're actually taking the operation body and we're using a text embedding model to create a vector representation of that. That's what's going into MongoDB's vector instance. So we ran that. You can see there's this whole vectorizing chunk stuff, so that's what went into Mongo. If we go back to our chatbot and we ask this same product question again, we didn't redeploy anything, we didn't change anything, it's going to be able to identify the persisted query along with executing that, and we can provide that data in the chat history to the chatbot. So we just gave it its first functionality. Now, if I'm thinking about the workflow of like, if I was here, oh, okay, cool, I see you sell some snowboards. Like, what about this archive snowboard? Like, I probably would say just like, all right, well, how much does that cost? I just copied that. There we go. And it's not going to know, right? Because there's no pricing information anywhere. We haven't created an operation around that, anything. Now, if we go back and we could add in that operation, or that field into this operation, but let's actually get like a product details, right? So we have our get product. And then from here, we now are going to want to put in a get product query. And there's, the same stuff here, right? We got a little description. You notice that the arguments, this is another opportunity for us to provide more context to LLM. We can make the argument just ID, but it's actually a product ID, so I just added that name in there. I can get as verbose as I want. All of it's just going to help the LLM. Run that same command. We're now just pushing that vector up into MongoDB. Now, if we ask that same question again, we haven't redeployed anything, done anything special. The LLM's actually really good at being able to pull out context and identify what the user means. So it didn't get a response, so that's good. Let's try that again. It's not a good AI demo unless something breaks inside of here, right? Let's see what products we sell again. Okay, so it's got the products. We'll do the 3P fulfilled snowboard this time. You wouldn't believe how hard this is with one hand. All right, let's try that again. What does this thing cost? Okay, all right, so it did what I was hoping it was going to do. The key point here is the LM was actually able to say, I said the 3P fulfilled snowboard. That's not what the ID of that object is. But because it has all of the data in the previous history of the messages, it's able to pull that ID out and put that along with it as part of the persisted query. So really what we're doing is we're using those vector scores to understand what is most likely the persisted query to get data from our APIs that the user needs. Now I think this really all starts to come together when you start adding in search. So the team actually added in a basic search functionality for us. So let's type in our search products. And so we have our simple search operation in here. I'll go ahead and ingest that. That's going to get put into our MongoDB instance. And what's really nice about this is a whole personalization aspect. So like I like snowboarding. I don't do it as much anymore, but I used to do a lot of backcountry snowboarding, and I would use a split board, put skins on, go up the mountain, get down. So, do you sell split boards? And the nice thing about this is the LLM is actually able to understand the intent and the entities that are inside of the question from the user. So it actually saw, I said split board, and you can see split board is actually what's being put as the variables for that persisted query. All right, and we got our snowboard back. So it actually got us exactly what we wanted, right? And all of this is in the form of a generic persisted query tool, just one function where its job is identifying what is most likely the highest vector score search similarity from a persisted query that's already in an operation list. So I'm really excited for this pattern. I think it's a really cool way where we can actually add additional functionality into our AI experiences without having to redeploy any code, and it's all just powered by the graph.
Nice. That's great. My guess is almost all of you have LLM or chatbot initiatives underway, and you've got a graph. So we'd love to help with this. If this is something you want help exploring further, find either the Apollo engineering team, or we've got a whole deep solutions practice, and we're eager to come and help you with your AI use cases and get those into production. It's exciting work. Okay. Look, with AI, with query planning, with connectors, and in a whole bunch of other areas, this is what we've been doing to make the community better, to advance GraphQL. We're at a time of such change and turbulence in how software is built, and we want you to feel good about your commitment to GraphQL and about what that's going to mean for you and for your teams and for your products. So thank you. I know that's a lot. The good news is we've got 2 days to really dive in. There's 40-something sessions lined up. We've got an Apollo lounge with a lot of our engineers that are excited to dive in deeper with you. We've got topic tables during lunch. There's just so much great content and so many great people to learn from here. These 2 days are about getting you all of that. We can't wait to see what you build. Enjoy the conference.